Hello everyone, welcome to one more session to discuss about equal sets. In one of the previous sessions, we already finished discussing briefly about subsets and equal sets. Still some of you asked about certain doubts regarding this issue. So here we are once more with a short video with a discussion on equal sets. Let us take one or two examples more to discuss about equal sets. First of all, let me take one example. If A is equal to 1, 2, 3, 4 and B is equal to 2, 1, 3, 4. In that case, we can say A and B are equal. We can read it as set A is equal to set B. If the elements of both the sets are exactly the same. At first look, they look different. See, A 1, 2, 3, 4. B 2, 1, 3, 4. But if you observe one by one, 1, yes it is present. 2, yes it is present. 3, yes it is present. 4, yes it is also present. Means all the 4 elements which are there in A are the same as in B. Otherwise, we write it as A is not equal to B. Equal to with a striked out symbol is called not equal. This happens if either A or B contains at least one element. One element is enough, not more. One element which is different from that in the other set. Suppose A had instead of 4 it was 5. It was 1, 2, 3, 5. And that 5 is not present in B. Automatically A and B are not equal. So also note one more thing. What we see in these two examples, they do not look same at the first sight. The reason is the order in which the elements are not so important. See, this is what we looked at. The order is different, but it should not be given much importance. The order is not important in which you write the elements, but the elements must be same. Let's continue with few more examples. Here we go. A, which contains 1, 2, 3, 4. B contains 2, 1, 3, 4. C contains 4, 3, 2, 1. And D contains 2, 4, 6, 8. In this case, we can say A and B are equal because the same elements are there. Only order is different. So they both are same. What about A and C? Again, same elements but in a different order. Again, A and C are equal. What about B and C? Yes, B and C are equal because the same elements but in different order. See, 1, 2 is found here, 1 at the end, 3 yeah in the second place, 4 yes in the first place. So all the elements are found same in B and C. So we can say B and C are equal again because same elements. What about if you can compare the numbers in all of these 4? The numbers are same. Actually, there is a separate word for this. If the number of elements are same, we call them equivalent sets. But we will not discuss it here. In another video, we will discuss that part. But A and D, if you compare, though 4 elements are same, 4 elements and 4 elements, number of elements are same, but the actual elements are different. See, 1 is there, no. 2 is there, yes. 3 is there, no. 4 is there, yes. But I said no twice. Even once if I say no, automatically A and D are not equal. See here, because 6 and 8 belongs to D. 6 and 8 are there in D. But the same 6 and 8 do not appear in A. At the same time, 1 and 3 are present in A. 1 and 3 are not present in D. Even in one of these cases, if you consider, automatically we say A and D are not equal. Let's go to check B and D. Look at B and D. Same case. 6 and 8 are found in D but not found in B. Reverse. 1 and 3 are present in B. 1 and 3 is not in D. That's why they both are not equal. Consider the last two. C and D. Are they equal to one another? C is containing 4, 3, 2, 1. But 3 and 1 are not present in D. At the same time, D contains 6, 8, which is not there in C. Because of this, we can say that C and D are not equal. Okay, let's continue the discussion. A set does not change if one or more elements of the set are repeated. Let us try to understand this. See, set A contains 1, 2, 3. B contains 2, 2, 1, 3, 3. At first look, it looks like A is smaller and B is a larger set. But 3 is repeated twice. Now, if you check the distinct numbers, which are different only, no repetitions, you get only 3 numbers. 3 numbers are 2, 1 and 3. Right? Only 3 of them. Same 3 numbers are also found in A. Because of this, A and B are equal. Though you feel B contains extra elements, no, it contains only 3 different distinct elements. So they both are equal. This is the main reason why we do not repeat the elements, because when elements are repeated, we exactly do not get how many distinct elements are there, what is the size of the set, we do not come to know. That's why. That is the reason we do not describe repeated elements in a set. Let's go for a few more examples here. I have written the rule method or the set builder method for A, B, C, D, E. Now if you carefully observe, first one is a singleton set 0. It looks like null set, but no, it is a singleton set. Now coming to B, it is asking for elements which are smaller than 5, at the same time should be greater than 15. There is no number which can agree to this condition. It should be bigger than 15, but it should be smaller than 5. That's not possible. So it's a null set. See, if you solve minus 5 goes to the other side, you get answer 5. So C contains a singleton set containing 5. D, it's a square equation. So quadratic equations always have two answers. The two answers are plus 5 and minus 5 by taking roots on both sides. And the last set here, that is x is the integral positive root of the equation. If you factorize this, you will get two answers, plus 5 and minus 3. But however, it is put that it is positive root, you will consider only plus 5 in the root. I'll write them as roster method here, the list method as follows. Okay, A is a singleton set with 0, B is null set, C is singleton set, D contains 5 and minus 5, E contains 5. Let me compare A with each one of them. What happens? A contains 0, but 0 is not there in B, 0 not in C, 0 not in D, 0 not in E. Means A is not equal to any of the elements. See, 0 is not belonging to any of the sets. Means A does not equate itself with anything. Okay, let us try with B now. But B, do not compare with A, already done. Let's start comparing B and C. Null set 5. See, nothing common. So they are not equal. Null set B, but none of them are null set. D is not null set, E is not null set. Automatically, B is not equal to C, B not equal to D, B not equal to E. Let us now compare C and D. See, in C there is only one element, D has two elements, and that is not repetition here. Minus 5 is there in D but not in C. Means they both are not equal. Right? There is minus 5 here, minus 5 does not exist there. One example is enough to prove that. Just one example, okay, to prove that it is not a set. So I take the same number which is not present. What is that? Minus 5. Minus 5 belongs to D, but minus 5 does not belong to C. So you can say C is not equal to D. Comparing C and E. C and E both are singleton sets with just one element and the same element, one and only 5. So we can say C and E both are equal because they both are the same singleton sets. What about D and E? Obviously minus 5 that means D is not equal to E. Thus the only pair which is equal here is C and E. All the remaining when taken as pairs are not equal. So few practice problems I am giving you here. Verify the equality of the following sets in pairs each. So first let us have a look at the sets. A is a null set, B is a set which contains elements between 0 and 5, and it should be purely whole numbers. Think and write the roster method. See, we have done enough examples in roster methods. I hope you can write all these elements as all these sets, I mean, as a roster method, right? The representation in roster method, you know. Now here C is set of all x such that x minus 2 is 0. So it's a very simple equation, x minus 2 equal to 0. I hope you can find out the value of x here. And similarly D, x plus 2 is equal to 0 and x is whole number. E, x is an integer between 0 and 6. Only integer values between 0 and 6 you take. F, 1, 2, 3, 4, 5. G, natural number less than 6. H, natural number less than 1. I hope they are all easy, and in case if you find any difficulty regarding these problems, Do comment in the comment section, and I'll try to create more videos and try to clarify your doubts. But do comment if you have any doubts or any part is not understandable. Thank you.